right, we're going to be spending the next couple of days looking at multiple angle and product sum formulas. So we're going to start out with these multiple angle formulas. You'll also hear me refer to them as double angle formulas. So same thing. Okay, so we're going to find this sine of 2 theta, cosine of 2 theta, and tangent of 2 theta. Well, remember that sine is opposite over hypotenuse. So we will need to find the hypotenuse for this triangle. So Pythagorean theorem, you have 2 squared plus 5 squared equals c squared. So this is 29 equals c squared, or c is square root of 29. So this side, square root of 29. Well, you know how to find the sine of an angle. So this would be the opposite over hypotenuse. So 2 over square root of 9. However, in order to find the sine of 2 theta, we need a double angle formula. Okay, so we're going to be using this first one. Sine of 2 theta is 2 times the sine of theta. Well, here, let me write it out first, and then we'll make our substitution. So it'd be 2 times the sine of theta times the cosine of theta. Well, we actually already took a second and found the sine, so it would be 2 over square root of 29. And then the cosine is going to be the adjacent, so 5 over square root of 29. I did not rationalize these. You can if you want to, but you'll see what happens here. When I multiply, I get root 29 times root 29, and that takes care of the radical for me. So I can kind of skip the rationalizing. I don't really need to do it. So on these, you can kind of skip that step, and then if you need to rationalize at the end, then that's easy enough thing to do. All right, now we're also going to find the cosine of 2 theta. Now you'll notice that there are 3 different formulas for cosine, so it does not matter which one you use. You will get the same result no matter what. I'm just going to use the first one. So cosine squared minus sine squared. Well, cosine is 5 over square root of 29. That's going to get squared. And then the sine is 2 over square root of 29. That is also going to get squared. Okay, so this becomes 25 29ths minus 4 29ths. And that is 21 29ths. So the cosine of 2 theta is 21 29ths. Okay, now for your tangent of 2 theta, same thing. I'm going to go back at my equation. So this is going to be 2 times the tangent of theta over 1 minus tangent squared of theta. So tangent, opposite over adjacent, so that's going to be 2/5, and then 1 minus 2/5 squared. So this is 4/5 over 1 minus 4/5. Oh, no, 4/25. So I'm going to need to get common denominators. So this is going to be I'm going to multiply by 25 over 25. This will become 4/5 divided by 21 25. So I went ahead and did 25 minus 4 is your 21. And then I have a fraction divided by a fraction. So multiply by the reciprocal. Okay. I can do some simplifying here. So this is 20 over 21. Okay, so there is example 1. Okay, now examples 2 and 3, we're going to be using the double angle formulas to help us solve. So we have 2 cosine of x. So this is going to be similar to what we did a couple of sections ago, where it might make sense that we can factor our equation on one side, and then that may help us to solve. Okay, so this one, 2 cosine x plus sine 2x. Okay, I'm going to make a substitution for this sine 2x. So I'm going to keep my 2 cosine x, and then my sine 2x is 2 sine times cosine. So 2 sine x times cosine x. Okay, now the reason I'm doing that is I can take out a common monomial of 2 cosine, and I will have 1 plus sine x remaining. So now that it's factored, I'm going to put each of my factors equal to 0. Okay, so now I am solving cosine of x is 0. So what angles whose cosine is 0? So on your unit circle, there are 2 angles. You're going to have a 90-degree angle and a 270-degree angle. Okay, then for this other one, I would be looking for the angle measures whose sine is -1. Well, it just so happens that is also 270 degrees. So I already have 270, so you don't really need to list this other one since you already have that one as one of your solutions. Okay, example 3. I'm going to move the sine x to the left so that I can make my equation equal to 0. And then again, you're going to be able to factor out, and this time we'll factor out a sine x. So it's factored. I'm going to put my factors equal to 0. So sine x is 0. Cosine of 2x minus 1 equals 0. So this is cosine of 2x equals 1. Okay, so sine of x is 0. That's going to be at 0 degrees and 180 degrees. Okay, then cosine of 2x is 1. So first we would need to figure out where cosine is 0 or is 1, and that's at 0 degrees. So then 2x would equal 0 degrees, so x is 0 degrees. So again, kind of same thing that happened in this previous one. I already have 0 as an angle measure, so I don't really need to list it again. Okay, so then this is the last example for today using these double angle formulas. So here we're going to find sine of 2 theta, cosine of 2 theta, and tangent of 2 theta. Using sine is 3/5, and you are between 0 and pi over 2. So if your angle measure is between 0 and pi over 2, you have an angle measure that is in quadrant 1. So let's sketch out this angle. So I'm in quadrant 1. Sine is 3/5. So 3 is the opposite, 5 is the hypotenuse. Pythagorean triple here, so the adjacent side is going to be 4. So I know that. So then I'm doing the same thing I just did a moment ago. So sine of 2 theta, the double angle formula is 2 sine theta cosine theta. So the sine, well, we already know that the sine is 3/5. I could go back to my triangle, but I'm told that cosine is 4/5. Okay, so here we're going to have 24/25. Okay, then we're going to go cosine of 2 theta. Now, again, you've got multiple options you can choose from. How about this time we'll try the second one. 2 cosine squared minus 1. So we're going to do 2 cosine squared minus 1. So this is going to be 2. Cosine is 4/5. That's going to be squared, and then subtract 1. Okay, so this will be 2 times 16/25 minus 1. So 32/25 minus 1. Again, I'm going to need common denominators, so I'm going to multiply by 25 over 25. So this is going to be 32 minus 25 over 25, or 7/25. Okay, and then tangent of 2 theta. Again, go back. Your equation for tangent is 2 tangent theta over 1 minus tangent squared theta. So tangent, opposite over adjacent, so that's going to be 3/4. And then I'll have 1 minus, and then this would be 3/4 squared. So this is going to be 6/2, or sorry, 6/4, or that would be 3/2 in the numerator. 1 minus 9/16 in the denominator. If I change this to 16 over 16, I get 3/2 over 7/16. And I'm going to multiply by the reciprocal and simplify, and you're going to get 24/7. Okay, so there's the tangent of 2 theta. So what we're doing here is, let's just say, for example, I'll just kind of make something up. Let's say this angle measure is 32 degrees. Okay, so then if we're finding the sine of 2 theta, we would be finding the sine of 64 degrees. Okay, and then this would be an exact way to calculate that value. So hopefully maybe that gives you a little bit of a frame of reference of what you're doing with these double angle formulas. Okay, so that finishes up kind of part 1 of these notes. We'll be back tomorrow with the next section.